Alright, so in this video we're going to be learning about distributed loads. This is just a quick introduction. If you want detailed examples, you can check out the written examples and they walk through those pretty clearly. A distributed load is a load that acts over a portion of your section. So for example, if this right here was some sort of roof and there's snow on it, say there's snow on the whole roof, the snow would act like a distributed load. Another example would be if this was the side of a building and the wind was blowing, the wind would be acting as a distributed load on the side of your building. So it's more of a force acting over a portion of your whole member versus just having some single force acting on it. However, we can take the distributed loads and break them down into single forces. So we can go from here and convert it to this. So we can evaluate it the same way that we would, so that way we can evaluate members the same way as we were doing in the previous examples. So to go from here over to here, all you have to do is take the area under the curve of your distributed load. So if we have a simply supported beam with a rectangular distributed load, and let's just say this is 10 pounds per foot. You might sometimes see this written as pounds per linear foot, PLF, like that. And the length of this beam is 10 feet. And we want to know what the force, the resultant force from this distributed load is. We just need to find the area under that curve, so the area of the rectangle, which is base times height. So in our case, the base is going to be the length of the beam, and the height is going to be our intensity of our distributed load, oftentimes referred to as omega. So it's going to be 10 feet times 10 PLF. So we're going to get 100 pounds. So we can redraw this as this. Now, how do you know where this force is acting? That force will act at the center of gravity of whatever shape of distributed load you have. So because we have a rectangular distributed load, we know that the center of gravity for a rectangle is exactly halfway through the rectangle. So this is going to be 5 feet, and this is going to be 5 feet. And this is equivalent to that. So, what if we had a distributed load that looked like that? and it was 10 PLF at the top. Beam is 10 feet long. Our resultant force is going to be equal to the area of a triangle, which is 1/2 base times height. So in our case, the base is going to be the length of the beam, which is 10 feet, and the height of our distributed load is 10 PLF. So we're going to get 50 pounds as our resultant force. So if we redraw that, we're going to get 50 pounds. And where is the center of gravity, or the centroid, of a triangle? This is going to be 2/3, and this is going to be 1/3. So this distance here is going to be 1/3 of 10 feet, and this is going to be 2/3 of 10 feet. If you don't know by memorization, or you haven't learned it, or you just can't remember what the centroids of different shapes are, you can find that pretty easily online, or pretty much in any statics textbook you can find a chart of this. It's usually in the back cover of your textbook that you're going to find that. But it's just as easy to Google centroid of a triangle, centroid of, a rectangle, and you can figure out what that distance is going to be. So then we have this being equivalent to that. So that's just a quick intro to distributed loads. Again, the thing to remember is distributed loads are equal to area under the curve, or area of the shape. And that will give you your resultant force. And then you can just remember that your resultant force acts at the centroid of the shape. Again, it's really just as simple as that. Don't overthink it. Sometimes you might end up with a curve that has maybe, say, an equation that goes along with it. Say this is like x squared. Again, it's just the area under that curve. And if you remember from calculus or pre-calc, the area under a curve is just the integral from 0 to L. And this will get you your distributed load. Again, to find your centroid, you can Google that. There's tables out there with all that stuff. So if you have any questions related to this video or any other video or any written example that you come across, feel free to reach out to me. That's my email, or you can use the chat function below, and that'll send me an email as well.